How's our angle? We have a good enough angle, and we're live. Go.
So, I'm Cal.
Shall we?
Someone in English here? Yeah. Yes. Let's do it in history. Would you prefer it with the accent or an American accent? It's better like American. Other like this. And so I'm Cal. I work at Superfly. I'll talk about Superfly in a moment. And because I'm improvising and apparently being processed on the website, but you'll forgive me. So I think what I'll talk about for the next few minutes is who we are at Superfly and a few of the problems that we face.
I should have preempted by saying not a vendor pitch.
Not a vendor pitch. And then I'm going to ask you guys to help us solve our problems by proposing ideas. Is this legit?
Yes, legit.
Wonderful. So a bit of history. Superfly started as a company that helps people find the frequent flyer miles. We realize that a lot of people have miles in the mailbox and they just don't know where to find them. Maybe they try to take them to New York and they don't know they didn't allow them. They can sign up for our website and give us access to their mailbox, and we can find all the miles in there. After we find the miles, they can come and search in the website and get the best flight for them. So we have this service for a few years now, and it's really great. A lot of it got a nice user base, but you can guess what our first problem is? Users. Money, right? There is no money in helping people find cheap flights. Travel is a horrible industry with really small margins. No one wants to pay you, and so that's the first problem we have. What we ended up realizing though is that we have access to a bunch of inboxes, and we notified our users that are different from our practical, and we basically track parse structure information for emails these days. So just like we can find frequent flyer files, we're able to detect receipts. We're able to detect bank statements. We're able to detect posted transactions and build an anonymous profile of what's going on in the market. So for instance, what is Uber's penetration to in Israel as opposed to get taxi? Or what are middle-aged techie guys buying on Amazon these days? Or I don't know. What is the average rate of return on lenders? So these are questions that we're able to answer by extracting structured data from an email inbox. And now our first problem, right? The latest one is user base. So obviously, if we're selling anonymized data, we're trying to sell statistical samples. And we always want a bigger panel and a panel that's more adjusted to the world. So we want to be able to take our panel of N and break it down and weight it to focus on users from Israel, users from Canada, users from the States. And here we're really open to new ideas of how do we get people to give us access to their inbox. So anyone with a quick idea?
What's this?
Hotmail.
What's this? We have the break solo and
Right.
so the problem is
Yeah.
it's okay now. We put it up.
That's right.
All right.
So without further ado, thank you for listening.
You are a Superfly, brave soul, and you are getting personal rights. We'll get that up. We'll even give you a discount code. Like I said, we'll go together for this brave soul.
So we did, right? So we did.
In a few minutes, Adrian and I is just getting connected. First of all, let's welcome Adrian to Israel. Thank you. Bring this up on substrate. Hope you're proud.
They were talking about taxi.
Okay, so I'll make this speaker an introduction, but we'll introduce him nonetheless. You're really Adrian Cockcroft, probably the most well-known architect, former eBay, and DevOps extraordinaire, thank you for joining us. Yes, we do. Here.
All right. So first of all, I gave a talk in June, and this is the Microsoft campus. Anyone here has that? So I looked at the slides and about some of it will look familiar, but I think that this talk is much more DevOps focus with developer focus. I rewrite my talks a lot. So,
Cheers.
right. So actually, I just did a summary of how many talks I do, and it's rather a lot. So this year I've done 40 public talks, 40.
Amazing.
Ridiculous.
Is 40 or 41?
I don't know that. This is included in that list somewhere. So anyway, so why am I doing this crazy thing? So one of the slides I usually put up says we're actually doing it to tweet that basically says baffling late adopters as a service. And that's kind of what it's felt like over the years, going out and talking about what Netflix does and why we do it that way. And why am I doing this right now? So I'm going to start off by just going through what has the reactions been to these ideas about cloud native and DevOps and whatever over the years. So the first thing was in 2009, Netflix said, well, we're going to go and do cloud. Nobody believed we were going to do that. But in 2009, Netflix moved some back-end things to the cloud, partly to try out the supplier relationship and see what happens when you ask for a few thousand machines. The bit that moved then was the things that the encoding of movies. So you take in the original movie from the studios, you crunch it, you produce all the formats, and we kept blowing up the few hundred machines we had in the data center. So we ended up with a few thousand machines, and then in the end, maybe 10,000 machines on AWS just for encoding movies. That's one account, one work group. And the other thing that happened was, as streaming got pretty busy, the logging information overran the logging machine. There was this little Oracle machine, and it was okay for logging for like a few things, but it just kind of got buried a little bit late. So we sent all the logging data to S3, but then we figured out we could use Hadoop. This is in 2009, so 30 other users with Hadoop. To process it in the cloud. So you put your data in the cloud, you process it in the cloud, and you delete it, whatever. So that was S3 and EMR. That was an EMR, which is an easy way to get Hadoop going into a Pyro cluster to process it. So that was kind of the basis. 2010 was when the website started to move to the cloud. So the first customer-facing piece went live in January. That was search autocomplete, just the simplest possible thing to just stand up controlling. By the end of the year, all of the customer-facing parts of the website were in the cloud, and APIs to TV sets and games consoles. So basically, all of the front end and the personalization engines and copies of the data needed to do that were in the cloud. But the back end, data sources, system of record for who the subscribers were still in the data center. So that's in 2010, everyone agreed that it's about not going to work, but we proved them wrong. And then in 2011, they said, okay, work for you with your unicorn, you're a unicorn, and I adopted the unicorn as my Twitter icon. Calling it Twitter's on cloudicorn, unicorn. So in 2011, there were a few outages caused by the back end of Netflix no longer talking to the front end of Netflix, and this is kind of hybrid cloud. Those of you who think hybrid cloud might be a good thing, it's the best analogy is a rodeo trick for riding, where you have two horses, and you see someone galloping around with one foot on the saddle of one horse, one foot on the saddle of the other horse, and you're holding a pair of reins in each hand. The only thing connecting the two horses together is your legs, and you go jumping through hoops of fire and doing tricks and jumps and stuff. And every now and again, the horses just get a bit too far apart, you go flat on the ground in a very comfortable way. So that's what hybrid cloud is. For those of you that are trying to sell it to people or having sold to you. It's really, really nice when you get off and sit on one of the horses, because then you've got much less to go wrong. And Netflix was just desperately trying to get off the data center because it was the old infrastructure, and it was unreliable, and those backends kept failing, and they kept getting overrun. So we moved all the backends to the cloud in 2011. That was when we rolled out Cassandra, and we were able to do backups and archives and build make the system of record be what was in the cloud. So that was the big change in 2011. There were some big outages for AWS in 2011, quite well publicized. Some of them Netflix didn't go down. One a little bit wobbly here and there, but in most cases Netflix survived much better than most people. Well, why is that? Well, we designed an architecture that was designed to stay up when the cloud was down. And so people said, well, we'd like to do that too, but we can't figure out how to get there because we built this enterprise architecture, 3-layer silo with an ESP in the middle. We don't know what to do. We can play service bus in the middle. And it doesn't look anything like what you built. So in 2012, Netflix started open sourcing its platform and now has 45 or so projects on GitHub. So, hey, now we can do it. So in 2013, I was doing roughly the same talk to people, but in 2013, people were saying, okay, we're trying to use your code, we just need help understanding it. And what are these gaps? And what are all these stupid projects with weird names that we can't spell? And it's a mess of, there was definitely no unified project management in the naming schemes. It was like, it's a mixture of Norse gods, Greek mythology, random creatures and animals, and acronyms and anything else that you want to name up. Basically, if you're an engineer and you are open sourcing a project, you basically got to pick the name that you built to do this. So what did we learn when we were doing this? And this is kind of what I started to apply outside. This is what I'm finding is interesting in my new job, which I'll get to in a minute. So speed wins. So you're a little company and trying to compete. The only advantage you've got is you can move faster than everyone else. You're like a mouse running around in an elephant. You just have to run fast enough. The speed don't land on your brain. You get that by taking friction out of product development. What that means is having a high trust, low process, no handoffs between teams, which is why this ends up looking like Devops. We sort of arrived at Devops from the developer end of the spectrum, whereas a lot of people started at the operations end and started just automating operations. What Netflix started doing was the developers just started operating. Right? So you can arrive at it, you have a slightly different tooling typically, but the end game is that you're mixing these two things together and you've got APIs to get things done rather than having that comes from having a freedom responsibility culture where engineers are empowered to do stuff, that they give tools, their judgment is trusted, and if it turns out their judgment can't be trusted, then they should be winning here. So there's kind of a bit of peril in the system. You have to, it's like being on a major league, say, baseball team. Like your batting average has to be good, and you mustn't have too many errors, forced errors, right? If you keep screwing up and your averages aren't good, they'll trade you out for a better play. That's the model Netflix uses. So if you're building a team, if you aren't keeping up with the rest of the team, then you're not moving everything forward. So they were trying to build the best team that could possibly be built. To simplify everything so that you could concentrate on building the best things and going fast, not that undifferentiated heavy lifting was moved out. So that is using AWS to build data centers for us, using all of the features of AWS that they could possibly build, persuading AWS to build new features. People worry about, well, if I put these features will be locking, and Netflix was like, please build more features. We don't want to be doing this stuff ourselves. You know how to run it at scale. We want to leverage that scale across multiple customers. We want to put our architecture out there. So everyone figures out how to use ELBs running. Everyone figures out how to use whatever pieces of autoscalers and things like that. So that's the key part. And as an architect, what I was trying to do was extract the patterns from what we were doing. I didn't invent most of this architecture. There were bits and pieces I was heavily influenced, but probably 80% of it was from just people we hired that knew how to do stuff. There were lots of very senior people that built things before. We had lots of debates. We tried stuff. We threw some stuff away. We figured out what worked. And my role as the overall architect was to gather up the things that worked, tell everyone about them internally. And what I found was the best way of telling people around them internally was to do external public presentations, because people pay more attention to that than they do to sending them an email and putting something on it. Right? It shouldn't look like that, but it does. So I really encourage you, if you've got an interesting architecture that you want everyone in your company to know about and start using, do a public presentation on it. You'll be amazed how well that works. The other thing was, instead of just speeding up what we typically did in the data center, I need 100 machines. Okay, well, I can get that in 10 minutes instead of 10 minutes and 10 weeks or something. I can now do things that weren't possible before, things that you could do, 100 machines, maybe operations guys can give you 100 machines, it just takes time. But can they give you 100 machines in Brazil today? Well, I don't have any people in Brazil, so I have to go hire someone in Brazil and go talk to Equinix or somebody, whoever has data center space, provision machines. And this is just impossible, but I need them for a week to do an experiment. And then I'm going to might not need them on my phone. Netflix did this. For a few weeks, we had 100 machines running in Brazil because Amazon has machines in Brazil and you can just fire up and try something. We do all these infrastructure experiments. You can actually do simple benchmark sort of experiments you would do on your laptop. You can do it on the cloud at immense scale. So we did multi-region database tests. We did scale tests, ridiculously large, multi-million-dollar installations if you had to buy it, but we only needed it for a day. So it cost $2,000 and eventually run, not even $2,000, sometimes hundreds of dollars. So you end up doing your benchmark really quickly because this is a big expensive machine, but you've learned so much. So we were able to investigate and learn which patterns worked. And that's how we got this stable at scale. We pushed it beyond its limit by factors of 10 in all kinds of dimensions as we were doing it. So it was always running in a very comfortable zone. So that's what I was doing. So what was the rest of the world doing? I was in 2009. Netflix started doing cloud. That's my good icon. And the rest of the world started paying attention and doing cloud. And the enterprise IT were ignoring it. Then they said no. And I said no, damn it. Oh no, oh crap. And everyone else is doing it. So okay, we should do it now. And so there's this interesting thing going on where enterprise IT is actually pretty much at this intersection point now. This is my new job. I'm playing around in this space where enterprises are absolutely piling into the cloud, and they don't really know what they're doing, and they're just adopting it because the boss said so in some cases. Some of them are doing much more awful things. But there's this huge investment going on right now to the private clouds, to the public cloud, to retool the enterprise. Somebody described as $1 trillion global reinvestment across the industry over the next few years, just to retool everything. So that's interesting. So I joined the venture capital fund, Battery Ventures. Some of you know, we have a local office, which is one of the reasons I'm visiting. I'll probably be I'll be in Tel Aviv probably 2 or 3 times a year going forward. That's my plan. So what's going on from the cloud vendors? How are they dealing with this? So one of the ways of looking at this is that there's actually a global land grab going on. And this is the Amazon part of that land grab. This is where Amazon has its region. So they just launched Frankfurt. We have two regions in Europe. That's something that's very interesting. Because if you look at all the other Amazon regions, they're mostly in places where it's cheap to put machines and cheap to get electricity, like Ireland, right? What's the cloud market in Ireland? It's really not very big. The local market is, there's a local market, but it's not going to line up your sales. But Germany, now that's a market. And that's probably the biggest market in Europe, single biggest market in Europe. You put a cloud in that market, and all of a sudden government and businesses and things that want their bits to stay in the borders, they want local jurisdiction and the laws for Germany to apply to their data. They say, okay, I can use this now. That's what we saw in Australia. When Amazon went to Australia, like suddenly lit up as one of the most advanced cloud regions. There are banks in Australia that are shutting down all their data centers and moving to AWS. It's the 5th biggest bank. The biggest bank is doing the work required to make the Amazon and Azure data centers treated from a regulatory perspective exactly the same as they've built their own data centers. So this is the most advanced use of the cloud that I've seen. It's actually in Australia. They're ahead of what the US is doing in some respects. So I think what you'll see is more clouds in more big markets rather than clouds in the little areas where it's cheap. This is where Microsoft has its clouds, and it has, I think, 19 now rather than Amazon's 11. they have a lot more regions, and that's partly because what they're running on their cloud is Office 365, SharePoint, and hosted Exchange. Most of the use of Microsoft Cloud are the internal apps that they've cloudified so that they can support customers and start offboarding those Microsoft backends. So you're seeing a lot more regional things because those need to be, they need jurisdiction and they need to be close to their customers for latency. So you're seeing a much broader spread of probably much smaller regions on Azure than you are on Amazon. Google's different again. They only have 3 regions. They have a central US, which is completely the wrong place. Amazon has this wonderful low latency network. They've got it halfway across the country. So it's much lower latency usually to get to US East than it is to get to the Google network, despite Google going on and on about how great the network is. But they really, really need to extend this. But Google really put this things where everything is cheap. They're in. They have more data centers than this actually, but I think they're in Belgium, Taiwan, and central US, somewhere where electricity is cheap. So that's the way it currently looks. Actually, I think I need to update that number to 11 because they just launched last week. These are the extra regions that when Google has a data center, but it is unable for Google Cloud. So they could probably add another 5 or so. They do have these West locations. They've got one in Chile, they've got in Finland, they've got something in Singapore. So I'm expecting at some point Google will need to catch up, but then they have to think about whether they can invest in putting Google Clouds where the customers really are. And that's, I think, probably going to slow them down. So, I made this statement earlier this year that this was going to be the year that enterprises really did embrace cloud, and I was really trying it out. Did people disagree with it? And most people seem to be agreeing with it, but there wasn't a lot of evidence. But then a few weeks ago, Lydia Young of Gartner came out and said, "What a difference a year makes." My Gartner symposium, one of the ones this year, everyone's already comfortably using infrastructure as a service, overwhelmingly understood a bit of Azure. Right? That's a year-on-year difference for October. That's kind of what I was seeing. But then last week was the Enterprise Devops Summit, the Devops Enterprise Summit in San Francisco, and you should just go find the videos and watch it. So this really separates it for me. Nordstrom went from optimizing for IT cost to optimizing for delivery speed. That is a big old company. They are one of IBM's traditional customers. That's about as old school as you can get. They've got mainframes, they've got all that stuff. They are now optimizing for delivery speed. These was MITRE, we had the Department of Homeland Security, the people that hand out green cards in America are doing agile. Seriously, they take things that took a year, now take weeks or days to do. They have Raytheon working on military projects for head up displays to tell whether you're about to shoot a friend or foe. They came under budget and faster and actually worked. It didn't cost ridiculous amounts because they did some sort of agile DevOps transformation. So lots of big companies, banks, all kinds of, the big stodgy companies, they call them the horses. This was the conference for the horses. Okay, we've had enough unicorns like Netflix. I did not stand up and present on stage at this event. We did an autopsy, a couple of ex-colleagues from Netflix. We did an autopsy of the unicorn where they tried to explain what was different about them. But the interesting thing was that just company after company doing amazing stories of the transformations they were going through. Pushing the wrong button. Pushing buttons on the wrong laptop. This guy is a Forrester VP, and he was at the summit on stage. He said, "This may be the very best conference I've ever been to." There we go to punch it on. That was because we got rid of all. I was on the program committee. We deleted all of the vendor presentation submissions, and it was end customers almost end to end. So it was amazing. So there are videos going up this week, next week. Go watch some of them. You'll get great ideas about what to do. So some of these companies are incumbents, and some of them are learning to be disruptors. So what is really the difference here? What are they doing? It comes down to this phrase. Is that what you don't know that gives you trouble? It's what you know that ain't so. It's the things that you're really, really sure are true that aren't actually true. Maybe they were true 5 years ago, but they aren't now. That's the things that break you. Because you made a bunch of assumptions about things that may be true or false, and you've embedded them in your business model. And now you have an optimized business that maybe has lots of revenue and lots of market capital based on those assumptions and the shared assumptions of the market. And somebody notices, you know, that assumption isn't really true anymore, and this thing that used to be expensive is now cheap. And if I learn to waste this cheap thing, I can optimize for something else that's expensive, I can solve the kind of problem for the customer. So that's the type of happenings. And there's a bunch of examples here. In the previous time I was here, I talked about solid state disk, basically taking over, you know, just changing all the assumptions in the storage layer. And people talk about converged storage, which is sort of all the storage in one unit, and that's hyper-converged storage, which is everything. And I talk about vapor-converged storage, which is the entire storage stack disappeared, it's all in the cloud, we don't need any storage people anymore. Turns out you can run a large-scale system like Netflix with some Java distributed systems developers running their entire storage stack. Right? That's very uncomfortable if you have to use stuff outside. But the assumption I'm going to look at here is really the Devops one. The process prevents problems. And what happens is organizations build up scar tissue. You see this in the laws of countries. Right? You know, every time something really bad happens, they make a law saying you can't do that. And you see it in the HR manuals. Every time some employee does something bad in the company, they write a rule saying you can't do that. And if you've been around long enough, your company's old, and every time you release a product and something goes bad, they have another check to make sure that that bad thing doesn't happen. So the problem is, it gets slower and slower and slower. And if you know any sort of people that were really, really good athletes, maybe professional athletes in their teens and 20s, you know, when they hit about 50, you know, they can barely walk. You know, they've got knee replacements, you know, they're arthritic, they've worn out their bodies, right, with scar tissue. And that's what happens to all companies, with all successful companies, is that they grind to a halt. That's what happens to countries as well. I mean, the US progress is completely dysfunctional right now. It's because it's got too much stuff. They keep adding more laws instead of actually going and removing laws. There should be a whole process to get rid of laws. So, what can you do? Well, there's a couple of books here which are sort of the guides for getting yourself out of this mess. If you're a manufacturing company, about 30 years ago, this book, The Goal, came out. It's part of the sort of MBA required reading list for a lot of people, and it explains how to use the theory of constraints and sort of statistical process control and things like that to speed up manufacturing processes so they can work properly. Now, Gene Kim, probably since you're the Devops group, you probably know who Gene Kim is, but he used this book as a template and built the Phoenix Project. Now, who knows who's the Phoenix Project? Good number. So I described the Phoenix Project. It's like it's the same block. The characters pretty much map one to one, except it's translated 30 years into the future to a time when companies can't figure out how to do software and their product development processes are broken. And it's a novel about everything bad that ever happened in IT. It's somewhere in there. It's a horror story. You will be wincing and it's uncomfortable. Oh, I remember that. Oh, I'm living that. Right? Those kind of things come up. About halfway through the book, the security architect of this company actually has a complete mental breakdown, disappears, and they find him a few weeks later, like drunken in a gutter somewhere. You know, it's kind of gets because of through the magic of DevOps. In the end, everything gets fixed, and these guys don't have that and all that stuff. So I describe this as the IT small training manual for anyone who's neck deep in alligators. There's this phrase. I don't know if you know this phrase. When you're neck deep in alligators, it's sometimes difficult to remember that your original goal was to drain the swamp. Right? That's I think the phrase, something like that. So this I put that in, but actually put it on it's on the back of the book. So it's my if you're in one of these big old companies, buy copies of this, do it to your management. So Target, the big American retailer, the ops guy from Target bought 23 copies of this book, made everybody, his management, his reports all read it, and like joint reading sessions, went to an off-site and acted out scenes from it. Don't have to go quite that far. Right? This is he was talking about this live on stage last week. Everyone's like, Okay. I think you win that prize. You win the biggest project fan prize. That's not really lost 40-minute protocol. This is independent of that stuff. But yeah, I think this is probably one of the reasons this guy is doing all that stuff, because of all the crap that happened. There's a lot of tidying up going on in these big companies. And, some of it is too late. Some of the tidying up is kicked off like even last year's events happening. Sometimes it has to get bad before it gets better. If you've got a life management, maybe it doesn't. So I'm going to talk about the product development processes briefly. And this is my favorite way to what continuous delivery looks like. That says observe, orient, decide, act. And do that for those of you into military strategy. So the first thing is we're going to try and innovate. Some companies can't innovate, but if you can innovate, that means you can see what customers are doing. You can see the land grab opportunities. You can see the competition making a move that you want to respond to. You see a customer pain point. So think about customer acquisition funnel, right? You've got customers visiting your website, and then they have to go through a bunch of steps before they finally sign up. And half the drop off, or 90% of them drop off, right? So the pain point is like, why are they dropping off? And you got to figure out what step is breaking. Maybe 30% of people don't like or can't find the button to push or something. So then you do some analysis. This is where the big data stuff comes in, because you probably have to pull in some log files that no one's ever looked at before, clean them up, cross integrate with a bunch of other data sources that no one's ever looked at before, but answer a question that no one has ever asked before. That's what I think big data is for. You want to quickly be able to answer these new questions with new kinds of data coming in. And so the agility matters on big data. It's not just about it being big, it's about being fast. So then you're going to plan a response, you're just going to do it, and you're going to share the plans, because this is an empowered organization with freedom and responsibility, and the developer that saw the problem, did the analysis, figures out what the plan is, has enough freedom and responsibility to prioritize that plan to above the line and actually do this one and to go and do it, but shares that they're going to do it so other people can say, hey, hang on a minute, this other guy just fixed that problem too, or those kinds of things, right? But you don't usually say, no, don't do it. You might try and talk them out of it a bit. If somebody really wants to do it, they get to go do it, because maybe their judgment is better. Then you use cloud to deploy an incremental feature. This is the whole new release. It's just a piece of the problem, right? You do automatic deploy, you launch it behind an A/B test, and then you measure the customers again and go around the loop again. So it's not quite like that, because you're actually going back and forth between these different things. The OODA loop is the one way it jumps around a bit more. But the key point here is that the faster you can move around in this diagram, the faster you learn, the more competitive you are, and the more the continuous delivery means you could be doing this multiple times a day for a single developer, and across a company that's hundreds of updates a day. That gives you the ability to respond in real time to things. Now, it doesn't mean everybody's running at that speed, but it means that you can go at that speed if you need to. So, how do you actually do that? And the problem is that most companies are organized into silos like this. There's a product management silo, that's user interface design, development, QA, then you have sort of DBAs and sysadmins, and there's meetings to go across these silos. If you want to get something done, there's a meeting, then there's a ticket system for talking to the guys back end, right? There's small meetings, probably talking to this is why it takes a year to do anything, right? Especially if you have to document every step, and there are stage gates, and you have to finish this thing before you do the next thing, this whole waterfall model. So since the waterfall is sort of embedded into the organization of the company, companies end up doing waterfall, even if they're doing agile here, the rest of the deployment turns into a waterfall. That's the problem. So one way that companies deal with that is they say, well, we're going to stick these guys up in another building down the street. They can do all their own stuff, and I don't care if they use cloud or if they have their own machines at some corner or some data center, and then you act like the startup inside the big company. You hear that kind of strategy. A lot of companies do that. So you end up with this sort of product teams basically doing monolithic delivery. They're doing it end to end, right? And they end up doing completely different stuff at the back end, and there's inefficiencies, and they don't learn from each other, so you're not sharing totally, right? And this stuff, there's a lot of automation that's needed here, so you're not building it. These guys use Puppet, these guys share, these guys now have I don't use full stack. Ansible, and you have the big nets where everyone's doing everything differently. So then if you further, you get these product teams using microservices where each service has its own API, and it has an API to the back end, and everyone decides to use Docker instead or something like that. And so the platform team have an API, and they know how to deploy Docker images, and the world is happy. Also, in the future, some people are getting there. But the idea is that there's a platform team that's concentrating on operating the stuff in the back end and building an API to make it work. And that, we call that cloud, if you like. But Netflix, that API is mostly to Amazon, although there's some pieces of the Netflix platform that fly on either side of that. There's actually several layers of platform. It's a very simplified model. But the key thing is these microservices can operate independently. But well, this isn't just little team speak, so that this is a real, this is, your management now is management by function. Right? The management that owns the customer sign-up flow, the management team that owns the personalization or owns the whatever it is, some other part. So these microservices are managed as groups of teams, and there is responsibilities that flow in this way. And those teams own, within that team, reporting to the same manager, you have everything from product management through, development, whatever, right? And you can borrow people across teams, but the responsibility lies within teams. So a little bit of low balance, they help each other out, whatever. But this is a real, and one of the sort of things to get people to understand, you don't do DevOps by creating the DevOps team or taking the release engineering team and renaming the DevOps buying the chef license. You do it by building a company so that your developers and your operations people are all mixed into one team. One of the big financial companies, and I'm not sure whether they were a better idea, I think they're an investment bank somewhere on the East Coast. They did a reorg where they just blended everything together. They have a mixed thing. Some of the managers are developers, some of them are operations, and they just blended everything into one structure. So we're not running anything separate. We all work together now. You're all combined teams. And they impose that on everybody in a large organization with, like 500 developers and more people or something like that. So that's one of the stories. How did they do it? A lot of shouting and screaming, I think. So the particular example that I was thinking of, the guy basically told everybody it was going to happen, and then he said he waited too long before actually doing it. What he really needed to do was concentrate on the managers, forget everyone else, get the managers aligned with what the new organization was going to be, concentrate on training them and getting everybody to understand what those new roles and responsibilities are going to be, and then make the move as quickly as possible. Because then there's this uncertainty where everyone's not quite sure what's going on, and it's so crazy it doesn't make sense, but then you lock in, but the managers know what they're responsible for, and things get clearer again. Right? So part of this was do it in 1 month, not 6 months, and concentrate a lot of that. He said he didn't put enough effort into training his management, and he took too long to do it. Those are the learnings from that one. I forget the name of the company's name, but there's a whole video of the guy doing. They were doing very advanced stuff. If you look at the architecture of what they were doing, it was almost like they read the Phoenix project and implemented every step in it. So this is part of the reason that conference came together was it came out of that sort of happening. So this is what a monolithic service looks like. This is what a small service looks like. If there's a handful of people in your company, it's just the right way to do things. You have a few people, you're using one tool chain, there's time to figure out all the one, you'll write everything in PHP or whatever. You have a QA team or person that does release integration, and you've got some ops, small ops teams that basically go to the chunk and move in the new one. And this works fine. It's very efficient. It lets you be very agile and change things a lot. And move things around when you're, particularly if you're building the early stages of the company where you're pivoting, you're not quite sure what you're supposed to be building yet. But at some point, you end up scaling up and having more people. This is sort of where problems happen. So if you imagine that you're going to go 5, but quite often you have 100 people working on one that they have, you get overhead. And you have a bug. QA finds a bug, and they go back to this one developer has to fix what they did. While that developer's fixing it, the work of all the other developers is blocked. So there was, a whole lot of functionality that doesn't reach the customer because of a bug. Meanwhile, everything's blocked. So what happens here is that you've got one bug talking to 100 people, you've got 99 people worth of wasted time and effort, which they did the value, but the value's not in the customers yet. So you don't find the next one. You don't iterate fast enough. It gets more and more painful. Netflix was in this state in about 2009, right? We had a monolithic application, and we had to rebuild it so that we could get out of this problem, because the building the release and releasing it was getting harder and harder and harder to do. We're getting more and more failed releases. So this is the story we had over and over again at last week's conference. People were just stuck in this, and they were taking longer and longer to get stuff out. So instead of that, you break everything up into microservices. You can start mixing your technology. So some teams can be using PHP or Python or Ruby or Go or Java or whatever you feel like. And the release plans are independent, the product managers are independent, and the teams are independent. They're on different schedules. They update at different times and at different rates, right? So the independence is really important. We'll talk about that later. The platform, though, basically takes whatever you did and wraps it in a container. Netflix used an AMI, Amazon Machine Image, basically it's a container to deliver everything to production. But nowadays, you probably use Docker because it's about 100 times faster to do. And that's why most people are doing Docker. Why a lot of people are. So you can wrap whatever the developers decided to use into a standard platform, and you can deploy it independently. Now, if I get a bug in one of these, I redeploy just that one, and everything else is already out there. So I'm no longer blocking everybody when I have a bug in one thing. You can still have interactions, but you treat interactions between these things as exceptions rather than the norm. You don't optimize for the case where you're going to have to interact. You optimize for the case where you have a stable interface and you're iterating within that interface. So if you actually do some change that needs broader coordination, you just organize that on a one-off basis based on whatever it happens to be. Right? So that's inverting the normal way people think of it. So, I mentioned Docker there. Why is Docker? I mean, what is going on with Docker? Why is it such an interesting thing? Well, one of the things is that if developers are using the language like Go, one of the companies I'm working with is Vivid Cortex. They build a MySQL monitoring tool. It's all written in Go. They have an API server, the entire API server. They put a lot of effort into it, a lot of code. Its compile time from scratch, from source code, is 400 milliseconds, right? It's like less than half a second to compile all the code to a binary, right? Okay, that was quick. And then you put it in a Docker container, which takes something to a second or less. Probably takes you longer to type the command or even get whatever. You need to script this basically. You're done. And then you deploy the container on your laptop, and that takes a second. Okay, now a few seconds after I finished writing my code, I've got it running. And then you go, you know what, that works well enough on my laptop, let's deploy the test. Well, I've previously deployed to test all the other pieces of the Docker stack that didn't change, like it was in Ubuntu, and there's a Go runtime and a bunch of other stuff. So the only piece that changed is my piece of code. So the only thing that moves to production to test is that piece of code. So it's fast. Again, seconds later, you're running the test. And then you go, you know what, that works, I want to put it in production. Seconds later, you're running production. Your entire run through this whole thing can happen in seconds. And that's, we thought we were going quite quickly when we could do each of those steps in a few minutes. And then with AMIs and bakeries and Jenkins and stuff, that would have a second. So then why is this viral? Like, okay, so if you start playing with this, and then you say, no, sorry, you have to go back to your old way of doing things and do everything 100 times slower, people can think nothing, right? So this is one of the reasons Docker is so viral. But what's happening is that once you've got this container, it's kind of messy. How do you deploy lots of containers? I was just talking to the guys at StarterScale, one of the companies that Adrian is involved in, and they're working on software that can try and deploy lots of containers together, not VMs or Docker images. And so Cloud Foundry and Google and Apsera, bought by Ericsson and Mesos, a whole bunch of other tools which are doing this kind of thing. So what they're all trying to do is figure out how do you get a bundle of containers that makes a larger app and deploy them correctly and all the stuff sticks together. So that's very fuzzy and confusing. And there's a really good answer yet. There's too many good answers, or too many half-baked answers probably is the best way of putting it. But I think what's clear to me is that before Docker, he's not arguing about that. That is developing very quickly. It's moving forward. There's a really technology out there. It's just almost agreed to go around that one, based on that one. So let's say core Docker is definitely going to happen. Which orchestration package is going to win? I'd say it's up in the air right now. So what's happening here is we keep trying to reduce the cost of the size and the risk of change, and that all increases the rate of change. Right? I can now deploy in seconds, so I can do it safely because it's behind an A/B test, so no one actually sees it anyway. If it's broken, it doesn't matter. Right? I actually do go test it myself and make sure it's okay before I can. So this is disruptive. If you figure out how to do continuous delivery of microservices, you're not really fast, you're getting stuff done quickly, your developers are happy, and you're pushing everything out, and your operation side is now highly automated. So keep talking about microservices, so let's try and define it. So I've got a coupled service-oriented architecture without the context. So a lot of people say, well, that's just SOA, right? That's what SOA was supposed to be back in the old days, when it was all XML and stuff and everything. There's a couple of problems with XML. So one is that if you ever look at every benchmark for how long it takes to serialize and deserialize XML, you realize that it's about 100 times slower than it needs to be. And so you make a nice big bundle of XML and you suddenly realize everything's horribly slow, right? It just is that way. The way you parse XML into an object model is just slow. So faster ways of moving data around between services is important. JSON is about 10 times faster than XML. Just arm-waving here and its order of magnitude. And if you're doing edge services, JSON's the right thing because browsers consume it directly. I can consume it directly. So there are some nice things you can do with JSON, but it's still relatively inefficient for complex objects. If you use protocol buffers or Avro or Thread, that's another order of magnitude faster. If you want to be an order of magnitude faster than that, there's a thing called simple binary coding, which is ridiculously fast. It's down. They're measuring everything in microseconds instead of the stuff that would take a second to do in XML. That is being developed for use on the Internet of Things, where every time you send a message, you burn some picojoules of your battery or something. Your battery goes flat, right? So having an incredibly efficient format is actually very important there. So there's an IoT company that's basically sponsoring that. The other people interested in SPE are the high-frequency trading people, because they are like quantum rank. Get that messages in and out there. So two sort of totally different worlds that care about latency and efficiency. SPE, but that one up, if you're worrying about this, and it's a bit funky to use, but that's because it's incredibly efficient. So what do I mean by loosely coupled? This is the key thing. The old SOA world, you had this centralized, what was it called? There was one of those XML sort of standards where there was a centralized repository where everything had to live, and you centralized everything. But then remarkably, when you centralize everything, it becomes closely coupled. It's not loosely coupled anymore. So you got the service-oriented architecture that was tightly coupled most of the time. So that was a problem. The other thing is, what is this bounded concept? So that is a book, that is a phrase from a book called Domain-Driven Design, or a discipline called Domain-Driven Design. But there's a book by Eric Evans. But this is the hard part. I don't have time to go over this. So the biggest, one of the biggest problems in management is how do you decompose a problem? Like I have a problem and I'm talking engineering or something, and how do I break it down across my teams? Like what are the right domains for this team? How do you organize domains for teams so that they own the domain and they have lots of internal chatter but relatively stable APIs between them? Like that's the domain decomposition problem. And if you're a line manager, you've got individual engineers who are trying to get units of work where they can work independently with relatively stable APIs to their code, right? So that is the problem of having a bounded context. What we're saying is that once you get your organization set up that way, the code follows that organization. It's just Conway's law sort of inverted. You build the organization to look like the code you want, and then an engineer builds an interface. So if you're a manager, you should understand what a bounded context is, how to do it. Read this book. There is lots of study stuff by presentations and whatever by Eric and stuff. But that's what it's about. Like, you don't want to slice something in the middle of a busy, chatty interface that's going to change rapidly, right? You want to have a domain that wraps that, but if you put too much in one domain, it becomes too much to deal with. It takes too long to learn how to modify it, and you've got too many unrelated concerns. So it's about getting things broken down there. Just one of those slightly archer computer architecture conversation. A hard problem, that's something that every good manager needs to know how to do. So having done all that, Netflix came out with one of these. Basically, it's an open source patent, series of patents for building high availability platforms, very high, large scale. This doesn't make a lot of sense to power up on your laptop. People have done it. There's like a Dockerized version of this on the laptop that Andrew Spiker put together just to prove you can do it. But mostly this makes sense if you have either more than a few hundred machines in it. It's a bit too much to get your head around if you're just trying to do something really simple. But it's immutable code, instant rollback, auto scale, a lot of automation around it. It distributes across availability zones of regions. When they globally distributed service, and there are some Internet of Things companies who have lots of traffic coming at them who result in this because they have potentially got tens of millions or hundreds of millions of people with things that are going to be sending them lots of traffic. And they wanted to build a globally distributed system. That is kind of what Netflix is. Next slide, I'll just explain what Netflix looks like from a system perspective. You end up denormalizing your data stores because one of the problems with having all those independent microservices is that they all talk to the same schema and the same MySQL database. You have to change the database before you can change all of the services you couple with them. So a lot of the time, the coupling ends up being data layer. So you have to forget all the stuff you put what we call it normalizing all your data, denormalize it, break everything into individual views and tables that can't talk to each other. Then you can't have transactions, you can't have joins because they do want in the same place, right? You can't have this transaction, cross-system transaction, you have to do in the application level. Joins on the application level. So you learn to do business logic level work that gets you around and just technical indigestion, trying to keep up with Teflon. So they came out with something new last week, failure injection testing. So an incredible piece of technology where they're actually decorating incoming requests with signatures that tell the system how to misbehave for that one request for the purposes of testing some piece of functionality deep in the system. They're tagging the thing, it goes all the way through. When it hits the right point, it generates the error, just one error. Then you see how that ripples out. And it's beautiful piece of technology. They felt like it wasn't when I left in January that they were talking about this. They came up with this thing, rolled it out, and they've open sourced it. They described it. I think they got open source. So what does this thing look like? So this is the US data from last April. They update this every. There'll be another one of these in November. This is the latest data. This is Netflix, Internet of Things, Internet of TV sets, according to Netflix, logging data about what movie you're watching and whether you're having a good time and whether it's buffered and whether your bit rate's good and all that kind of stuff. So there's an enormous amount of data being sent in from many millions of TV sets currently hammering, and it adds up to 6.4% of the total bandwidth of the internet in America at peak time is data coming into Netflix from customers. This is movie data, right? And it's going into the Amazon ELBs, basically. Right? That's more than YouTube uploads. It's crazy, right? So going down, Netflix is 34% of the internet. That goes through a totally different system. It doesn't go through AWS at all. It's an Open Connect, which is the name of the Netflix CDN. It's basically a raw box with hard disks in it, Nginx, and nothing else. It's just Nginx static files, HTTP, and all of the intelligence is in the client and in the cloud. This is just a way to deliver big files, and it's several petabytes total, multiplied by however many places. This is the CDN. This has, arguably, going on sort of, data might be a few months old. A few months ago, we were roughly doing about the same total global bandwidth as Apple. This is the Netflix private CDN. There are two big private CDNs in the world, this one and the YouTube one. Right? They are both big, but Netflix is bigger than YouTube in total bandwidth. This is not the number of videos watched. If you look at video, tend to be watching video at 5 megabits, right? And you watch it for an hour or 2 hours. continuous streaming, and then there are just millions of people doing this at once. So that's, you multiply the numbers up. That's why it's so big. They had to build their own CDN because they outgrew Akamai Lifetime Level 3 put together's ability to run this. And they were just overrunning them. This is a much simpler product. The Akamai product has all kinds of clever features. It's incredibly sophisticated. Most CDNs are. This is the dumbest CDN you could possibly build. It's a box of disks with HTTP GET. Right? There is no patch misses. It gets uploaded with the movies you'll need tomorrow overnight. Right? It's done. Right? No business logic on it. But the Nginx guys are happy because they are most of the world's bandwidth of the internet goes to Nginx now. So just to talk a bit about monitoring and how to deal with this stuff. So when you build these systems, the high rate of change tends to break everything because everything looks new. When you auto scale a group of machines up and down, the way you do it is that the old machines get taken out of service as you scale down, and new machines get added going up. So you tend to turn over your entire peak every day. The peak, the machines only live for 2 or 3 hours. Right? So the average lifetime of an auto-scale machine is maybe 6 hours or 12 hours or something like that. Across all the systems, Netflix has. At one point we calculated the average across everything was a day and a half. There are some machines that are there for months, but there are also a bunch of machines that are there for an hour. So machines come and go, it's totally dynamic, and then code pushes is, hey, I need 1,000 new machines all at once. So everything looks unusual. It's a bit, most tooling breaks, so there's a whole set of problems around building new types of alerting and monitoring around these. You can't have a ticket to edit your Nagios configuration every time you do code push when there's 30,000 machines walking around and 10,000 will go away every night. The other thing is the end-to-end request flow, trying to get calls mapped from one point through the system to another point. Right at the end, finally, I'll show you my little D3 prototype for trying to visualize this. So ways to visualize this the other one. So then how many microservices do you have? Well, that's a moving target. This is Pilgrim. They started as a year. They started with no microservices and ended up with 450 after about a year. But it's still going up. I'm not really sure how many. There is no answer. You just, the more work you do, the more microservices you end up with. So the job of just adding them. Occasionally you retire a few, but generally you just keep adding. So you end up with these architecture diagrams. They're called the Death Star. This is the Netflix architecture diagram, the Twitter, and there's 3 or 4 companies that have the same architecture diagram as Twitter because that's a D3 core graph, and they're all indistinguishable. They look the same. But this one, they only show 12 of their nodes, so they're cheating because they had 450 on the previous slide. And this is an old version of Netflix before it got really complicated. Basically, the green bit goes completely solid at some point. That really is about 3 years ago. So, and then everything's changing. And the individual changes are going to be more common, and the developers deploy the code when they think it's okay. They turn on the big toggle, and then a whole bunch of customers get the full experience that only is full time testers were getting for a while. So feature flags. So if you push a feature flag, then you go, okay, monitoring system. Okay, it takes about 3 or 4 minutes for the first data point to turn up. I'm going to get that coffee. Right? And then you're standing by the coffee machine, and you suddenly realize everyone else is running around. There's an outage happening. And you suddenly realize it's your outage, you caused it, and nobody can figure out who caused that thing. And you have to go toggle it back, and then you wait 10 more minutes to make sure that you did toggle it back correctly and everything settles down. So you have like a half-hour or an hour-long outage. So after multiple events like that, Netflix, we did 2 or 3 things. One is there was a central log of everything that changed. Right? And it does not only include I changed this configuration variable, it includes the previous value of it. Which is also something that we discovered we needed after building it the first time. Right? So there's a system, it's called Kronos, it doesn't matter, it's fairly simple. Quite a few tools have this built in, like AppDynamics has one of these, Boundary has one of these, they have APIs, you can document it. The point is that everyone has to agree that everything that changes production automatically hooks this API and says, I just did a thing, right? And it gets logged. And when everything breaks, you go look at this log, what was the last thing that you did happen before it broke? It's usually the thing that broke. In not always, sometimes things take a while to build up. But you can see that log is just immensely and your mean time to respond to bits will get way better. But what it still takes 10 minutes to notice that it's broke, right? Unless customers start calling central call. So what you really want to do is take 5 seconds instead of 5 minutes. And you do that by having tools that give you 1 second updates instead of 1 minute updates. So this becomes more and more important. You want to be able to push the button, and then you sit there for 10 seconds, and you say, okay, everything looks good. Now I can go and get my cup of coffee, right? So, but because within your attention span of sort of 10 seconds or so, you got data that showed you everything was okay, or you saw, oops, everything broke, quick, flick it back off again, maybe nobody noticed. Yes, that was within the retry window of everyone's browser. It would have just went a bit slow for a second. Okay, so you can get away from a total outage and have nobody notice because there's enough retries in the system will just recover. But that can become really tough. You could have something that broke everything. As long as you do it short enough. So one of the tools that Netflix open source is the circuit breaker bulkhead code called Districts. And Turbine is an aggregator for that basically takes a whole lot of machines that are running circuit breakers and aggregates them into this view. This is not a tool. This is you connect your browser to a URL on your API server or whatever machine you've got that's running this code. Right? You go in on a separate port and it opens a WebSocket and starts punching JSON at your browser. So this entire dashboard is the first, the framework for it is downloaded into your browser. A bunch of other bits and pieces, right? So stuff gets thrown into your browser, and it continuously updates once a second. There's nothing in between. It's just your browser connected to Turbine, which is an aggregation point, which is gathering, taking all these WebSockets and turning into one WebSocket, right? Because you can't connect to another machine, so you want to see the output. So that's what Turbine and Districts do. This has been adopted by a bunch of people recently. The Scala hacker group, I think, is using it. Typeset, the company, they started adopting it. There's versions. This is getting ported because the idea is good and it works well. And what happens is something breaks and the circuit breaker goes, I'm going to be red and I'm going to stop calling this service because it's broken. Every time I call it, it breaks. I'm going to stop calling it. I'm going to return some default value quickly. So you do a fail fast. You return some, standby fallback value. Right, maybe the last thing you hashed or some fixed value or something like that. You don't just call it and wait. So you end up not propagate latency out your stack because but you call it every now and again to see if you got better, if it got better, if you need to learn. Sometimes they get better on the run. So there's a couple of SaaS-based monitors that do this. I mentioned Vivid Cortex before. This is this MySQL monitor. It does 1 second monitoring of your MySQL. It will find things that are broken you did not know about. You're running MySQL, they have a sort of free trial, try it out. You just load your agent and go and visit their portal and then monitor it. Try that and test or something first. It's a nice tool. And then Boundary that does this for that looks at the network flows in the system. Both of these basically are the network flows. Boundary looks at it on a local basis, and Vivid Cortex looks at it to try and understand what's going on. So I try to encourage more and more tools to have more high resolution monitoring. So this is, like I said, you need to be able to deal with this quickly. If you're really deploying really quickly or really frequently, you have to have a different monitoring. So what we're trying to do here really is separate concerns in a new way, not separate the concerns of the SAN admin from the sysadmin. Right? We're trying to separate the concerns of the sign-up flow team versus the personalization team versus the billing team, right? So that's most of the content I've got, but I've got answers to some common questions that keep coming up. Yeah, I'll share that up. There's a few things, questions I get over and over and over again, so I ended up just making slides for them just to save me the time of asking them. So this is one of them. I was talking to a whole bunch of high-level people, and the CTO said, "Well, you have this superstar development team. We don't have a development team like that. How do we do that? We can't do this stuff because you have these superhuman people." And I had this about we got a big bat where we clone, right? We create those. It doesn't work like that. Where did these people come from? And I managed that this is one of those moments where your brain actually clicks in, came up with the right answer. And instead of like the next day, like it usually does. This is what I said. We hired them from you, not out of their way. Because I looked around the room and I said, okay, we had 3 guys from Cockcroft, we had a guy from Young Foods, we had, we had the guy from there. These were all people that used to work for you guys. So you probably still have people like this in your organization, but you're not developing them and you're not giving them the ability to act the way that they would act if they were Netflix. Netflix has creamed up the superstars of everyone else, right? And got out of their way. So how do you do that in a big company? Well, I got one model for doing this, which was when I was at Sun Microsystems. I was one of the distinguished engineers, and that's kind of a model for doing this. Where you take individual people and you make them sort of director level or VP level contributors, and you take work away from them, you take responsibility away from them, so they have time to think, and time to noodle around and try stuff, right? Incredibly helps is the best person in your organization. You're taking them off the front line, like everyone has to now do the work without them, so they have new habits. This is the hard part, right? Take your best people and set them free to think, try stuff out, and roam around the organization giving advice to people, but not having responsibility for stuff. So that people say, get out of these, they turn out to be doing it all wrong and disappear again. That's kind of what this was. Right? But you should listen to them because that's why they're distinguished. So that works for really senior people with great hair like me, right? There's people that Netflix who were Xerox party betting objects in the early 1980s, so they actually looked at Netflix. What about the junior guys? Well, the other program that Netflix had was a mentoring program, which we called the Bubble program, Best on Best. We looked at new hires, graduate new hires, people almost straight out of college, and tried to select people who looked interesting, who've done something interesting already, or were just seemed particularly up. And then they all pitched to the DEs, and the DEs had to individually adopt them, right? So you get, depending on how much bandwidth you got, you would adopt 1 or 2 people as mentees, but it's up to you have to convince the DE of your particular specialty that you are the person that should take their time. So now you've got a group of like proto DEs on a sort of fast track, right? Getting extra attention and being mentored forward, and their ideas are being listened to and spread amongst them. So that's kind of what it sort of worked for Sun. There's some very cool people in that community. I was really honored to be part of it. I snuck into the road book. I wasn't really anything like it. But there's a couple of models for doing that. Right. So another thing is where do you start? How do you get into Devops? How do you do this real when you're already siloed the other way? So most companies have at some point had to deal with putting something in the App Store, right? So they have to build an enterprise mobile app or something. And you have to build it as a horizontal team. So there is somewhere a product manager, a UI designer, a developer, maybe the same person, provisioning their app to the App Store. Right? They're not talking to Devops. It's a horizontally integrated team. That's what all your teams should do. Right? So make everything look like what you did to make that mobile team happen. That's kind of the model. And everything is API driven. You do mobile apps, they call APIs in all different directions. So that is the new model. Make everything look like your mobile app team. That at least you possibly have a seed of that in your organization. Then, okay, thinking about using cloud, how should you sort of get the toe in the water? So the first thing is archive data in the cloud. You want data diversity, you should be putting things on tape nowadays. Really, it's expensive, annoying. So build a back-end data store that copies your data into the cloud and archives it there. And you can archive it into multiple clouds, and there is the Amazon cloud is where Netflix puts most of its backups and archives. It usually encrypts everything and then puts it out there, right? So it's pretty safe. Anything in there. Google has this neat trick where they have a tool which you point at S3 and it moves everything out of a bucket and puts it in Google. It's called Meetup. If you know Spaceballs, the movie, there was that thing that was sucking the air, the Megamate. They call it Meetup. Megamate, that's right. It's sucking air out of the planet. Right? There's this transformer made with a so that's their code name for it. And basically, it only works one way. It will suck anything out of S3 into Google Cloud. continuously. You set it up and ignore it, and your data will just be there. You don't have to write code, you don't have to do anything. You just have GC util, point it up, set it up with an authentication key so that it's got permission to read that bucket, you're done. Right? Now, if you lose all your data over here, you've got another copy somewhere else. So for disaster recovery, you cover 2 cloud copies of your data. That's the Netflix archive. You have there's multiple regions you can store data. It's a very, very nice way of doing it. So the other thing is, so when you start playing the cloud, what is another thing? Well, let's say all of a sudden we've got customers in Australia, but the latency from there is forever. Well, instead of trying to figure out how to put your data center app in Australia, just use the Amazon cloud. Use the cloud to create a new region where you couldn't really invest putting a data center in, or it would take too long. So use the fact that the cloud is global to solve a problem that you have, a business problem you have, it would be too hard to solve somewhere else. And when you put something in the cloud, put it in multiple zones. They're called availability zones for a reason. They sometimes go away. Right? So Netflix runs on 3 zones, and each reason it will run on them when one of them is down. Right? So you can lose an entire third of the infrastructure, and once a quarter Netflix deliberately deletes a third of its machines in each region to prove that it still works on the other 2/3. Right? That's called chaos pop. Chaos Gorilla does that. Chaos pop is a whole region. Chaos Gorilla, chaos pop is a whole region. The other thing is, like I pointed out, when your tooling for the data center is not likely to be working in the cloud, but some of the new generation tools that work in the cloud are designed to work in both. So one of the migration blockers you'll get as you try to figure out how to do cloud is that you need to reboot. You should be looking at some of the next generation tools that understand dynamic systems and cloud native and whatever, and migrate to them from your Azure or whatever you're currently running, right? So to make that migration in advance of it. So that's kind of some of the starting points. What about costs? It's cost more. Get that from a lot of people, but depends how you do that. And I'm supposedly giving a talk, but I haven't actually written it yet, for cloud native cost optimization, and it's in about 2 weeks, so I actually have to get on and write it. They've been nagging at me for about a month now to finish it. So I'm just going to summarize like what I'm going to put in this talk, and then have to look for it, which is, the first thing is, if you turn stuff off, you stop paying for it, which is magical, because in the data center that doesn't work. You power something down, it costs a bit less because you're not using electricity for it, right? So most architectures don't have that concept in them. And data center machines are not designed to be turned off. Applications aren't designed to be turned off, right? When you go home at night, your entire development and test environment that no one's using overnight, you just shut down. You just collapse the disk space, and there should be no instances running. Then you come in the next day, and in 10 seconds, stop will be created as images or whatever you've got, right? You should be able to do something like that with your entire test development environment, because you'll be using it for the 8 hours. So you get back 2/3 of the cost immediately, and weekends, hang on, so that's like you get back 3/4 of the cost, right? So you just cut your cost of cloud to a quarter by turning stuff off, right? That you're not using, and a lot of time you're using those things. The other thing is capacity of demand. When you deploy something in the data center, you're not quite sure how much capacity you need, so you get a bit extra to last you maybe through the end of the year, and you have a bit extra, right? You're a bit too close in case you suddenly spike up, quite often you run out of capacity to scrambling platform, right? Well, in fact, you don't allocate it until just before you need it, you have just enough. So that means there's kind of a ramp-upping capacity instead of a total capacity. So you can, what Netflix found was the difference between those two actually, it was turning machines off at night would save 70%. But compared to having a fixed number of machines with the traffic going up and down under them, when you start tracking, when you come to have just enough machines at every point, the area under the curve is only 30% of the area under the big curve. So that's about a third of the cost, right? So that's your production stuff is running at a third of the cost, and your test environment's running at a quarter cost. That's before you did anything else. And then there's understanding all of the consolidated billing and reservations and all of the complicated stuff about optimizing the way a particular cloud vendor works. That's another about, you can save about 3/4 of your money if you do that right as well. And then the other thing is, in your data center, there's a lot of tooling that data center vendors like to sell you. a lot of that tooling is actually baked into public cloud vendors, and a lot of the additional tooling is free because you just get it on GitHub, and so you can actually save quite a lot of money on tooling and the cost of running stuff and supporting it. So you can still buy licenses to support things, but generally speaking, I think cloud-native tooling is generally cheaper than enterprise data center tooling. So the license cost per machine for monitoring it or whatever tends to be. So that's, I'm going to write a whole 40-minute presentation on that. You get a general idea. Yeah.
Let's go to that. Is there a tool that you do that on the database layer? Just so scale down, yeah, for example, scale down the side of that.
So I used to scare my development team by having ideas on airplanes when I got bored. You know, no internet, no Twitter. So I'd sit there and dream up ways to benchmark for Cassandra. And I wanted to do that. And I tried to get a project to auto scale it. I did a benchmark. I did a demo actually at the Cassandra Summit, I think in 2012, where live on stage in a 1-hour talk, I created from scratch 2 Cassandra clusters, and after 15 minutes, doubled the size of both of them. And then after another 15 minutes, shut them all down after about half an hour, 40 minutes running, and then summarize what happened. It's SSD versus spinning rust. That's actually what I was testing. But I did double the size. Right? That was scale up. The scale down is harder, but that was trying to get them to do that. The V nodes should know, but V nodes don't work all the way. So there's a few things that don't quite work there. And I think it will come one day. It wasn't part of the design for Cassandra. Cassandra was not designed for cloud in mind, really. So I think that there's probably a scale up, scale down database out there in the future. And I think it's probably going to be written in Go. About 3/4 of all the new stuff I see is written in Go. I just learned Go this summer. It's a really productive language. If you've ever written anything in C or Java or C++, it's pretty quick to learn. It's actually quicker to learn than Java. There's much less to it, and it's quite productive. So people generally get into it and like it. So I'm just observing that most of the new stuff I see is written in Go. I mean, not everything, but from a year ago, there were a few things. Now it's Apsara for Go, Cortex, sometimes you can rewritten in Go for Ruby, lots of stuff. So the other thing is this book, which has been trying to get out for the last year, but is just, I think, finally going through last days of copy editing. You can get a PDF version of this book, the Enterprise. This just summarizes what I was talking about earlier. Enterprises are adopting continuous delivery, Devops, and lean startup at scale. They are doing that. This is a book that describes how to do it and the story of some of the people that have done it. So the other one is this whole monolithic to microservices. Most people haven't really heard of microservices a year ago, but the whole Docker story is intimately tied up with microservices. As soon as somebody starts asking, what is this Docker thing? Why is everyone going on and on about it? You end up explaining microservices to them as part of the answer, because that's what the Docker guys are talking about all the time. So I think these are things that I'm interested in what I'm playing with in my new role. And if you've got any questions, you can find me at battery.com. There's a blog that I don't update very often at CodeCat. I'm Adrian Code on Twitter. And then there's a bunch of talks I've done. There's various versions of this talk have been bits and pieces of these different places. Some of them there are videos. So come across the long version of my monitoring tool. And I have to write. This is a small subset of the talk section. Okay, so that was the last slide. Any questions, or people have to rush out of here? Questions? Yeah. So the question was, Netflix sometimes builds its own things instead of using the Amazon thing, right? There's two reasons that happens. One is timing, like Netflix needed it before Amazon built it. Netflix was talking to Amazon about we really need a database in the cloud, and we need it on SSD. But they said, well, we're going to do this DynamoDB thing in about a year. It's going to be based on SSD. They said, okay, give us the SSD. And they said, no, we don't want to. No, really, give us the SSDs. We wouldn't shut up until they gave us the SSD, which is what I want for it. That part of it, I didn't think was ever intended to go out to end users. We figured out that we really didn't need it. There are products that service. There are people in Seattle who are just located shortlists. There's a lot of interesting. Every week there's like a meeting president that gets these field things. So that's one answer. So DynamoDB came out too late. It still doesn't have multi-region replication. It's missing some features. So again, we use that. We reuse later. Last year at reInvent, they had this big crowd thing. We do a bazillion a month requests into DynamoDB, and I back calculated that into a per second rate, and it was less than Netflix's biggest Cassandra cluster does. So that means that every customer using DynamoDB added up together is a bit smaller than one of the big Netflix clusters. So you can't be a shark in a paddling pool. It's supposed to be a small fish in a big pond, right? You don't fit. Sharks don't fit in paddling pools. So that's the problem. So there's timing and there's scale. So you mentioned the what's it, Kinesis? So they have Kinesis, which is a logging system. Suro is the Netflix logging system. I think Suro is about 100 times the capacity of Kinesis. There's 2 orders of magnitude somewhere in what it can do because of the traffic that Netflix needs to put through. And it's also built before Kinesis. So you can actually tap data from Suro into Kinesis and send it from the center of the traffic. But yeah, so Netflix has got too big. There's 30,000 machines. So ridiculous amounts of traffic. But yeah. So other stuff like Netflix has already figured out a solution before the Amazon things like that. There are products where Netflix had an internal thing, like IAM came out, Netflix retired some internal code, but that came out. There's a whole bunch of things that Amazon is doing which gradually let you retire. This is a philosophical thing. Netflix decided it wanted to own its own platform because if you put a vendor in the middle, like say a RightScale, they want to own that middle, they want to expand their value, right? So they want more money and they want to increase their value. Whereas if the platform underneath is adding value, you want to keep removing pieces of your platform, replacing it with the standard cloud thing. So you end up with a thin layer of platform that keeps moving upstream, right? And you remove the old parts of it. So by not having a vendor between Netflix and AWS, you're able to track what AWS did better and leverage it, and not have this other vendor wanting to be like the cloud. Yeah. What monitoring tools are we using? So at Netflix, they built an internal thing called Atlas because everything else broke. That Atlas broke the first 4 or 5 times it was architected. It's a moving target. It's ridiculously big monitoring system. It's very inefficient. No one in their right mind should ever try to run even Netflix. It just consumes too much. It's a huge in-memory buffer for a ridiculous number of networks with ways of slicing and dicing it. You might try to solve it sometime. The other tool they use is Boundary for monitoring the Cassandra backend. So you think about Cassandra, there's 4 data flows from a Cassandra node on the network, and normally you can't see, you just see, hey, I'm doing this much on the network. You can't see how much is going on each flow. So what you want to see is how much incoming traffic is coming from this plan, how much of that traffic goes cross for replication synchronously, how much is going cross region for the wide area replication, and how much is going to back up to S3. Right? So there's 4 different flows, you monitor them, and if anything goes wrong with one of those flows, you have a really clear idea, hey, this zone can't talk to its zone next to it. You can see that, right? And then Boundary also aggregates across nodes in the zone and across an entire Cassandra cluster and across all the clusters. So you can look at the total replication traffic from US East to US West, for example, you just do that total traffic because it's got some nice aggregators across that. So for that, for things where you've got lots of different traffic flows, that's a nice tool. Again, it blew up quite a few times trying to get it to work because there's several thousand nodes in Cassandra, but that's not the problem. Most tools outside just blow up like that. Anything increases so eBay had that problem too. They're building your own tool.
So there's something about the side game of the market for the using and the level platform interacting with the
Performance tuning and the platform.
I mean, building the making your development system more in order to integrate.
So initially, the platform tooling was built by, the first version was probably built by two people. One person that basically made the AIs and the bakery that you had them could build stuff, and somebody else that built the tooling that the developers used to push code to it. Then somebody else built the Jenkins pipeline that automated the build a bit better, and then they hired more people, and that team is probably, out of about 500 engineers, the platform tools team is probably about 10 or so. But they've got a fairly mature system now that leverages a lot of existing stuff, right? So you can start fairly small and grow there. Overall, there's another part of that question I was going to answer. Right?
This includes the configuration management of the
yeah, the configuration, they built a configuration management tool. There's a couple of them, they've been open source. Meetup is like a black box flight recorder for the cloud to record the entire state since the dawn of time for an Amazon account. Every change that ever happened in that account is recorded, so you can say, what was the IP address of every API server last Wednesday when we had that outage? Because they're all different now. So the log files don't make sense anymore, right? So you have to be able to find back to the point to Meetup, and it's a standalone Scala app. Just fire it up and run it up. You know when you lose an aircraft over the Pacific, eventually they find the remains and pull out that thing, right? They don't have a black box fire recorder. You won't want it until you really need it. It's one of those things that should just somewhere you should just fire it up and run it and get it out. It's got a nice API for finding out what's going on. So a lot of the Netflix monkeys run against that API because they can do queries against the backend for what change, what's going on. The other thing I wanted to mention was the performance team at Netflix. There's a central performance team. What they do is they look for the most inefficient, largest scale problem, which we call a low-hanging watermelon. It's a low-hanging fruit, and you tend to ignore the low-hanging fruits or blueberries, right? So you want to go for really big, fat problems where there's lots of them, and then you get a great return on investment, and you ignore the small stuff, right? Individual developers usually don't have enough context to know whether they should be optimized, so they should just get them out quickly. But if it turns out to be slow and inefficient, somebody who's a performance team turns up and sits next to them for a few days and magically gets 10 times faster. Right? There's usually plenty of fat for tuners. That team, Brenda Gregg, the E-Trace guy, joined that team February or something. He's doing a talk at Meetup that was pretty much at the top of the list of talks. So, very good stuff. There's a central team that manages Cassandra, and that team does two things. They manage Cassandra itself because there's a code base that needs a lot of updates. So the individual developer can deploy a Cassandra cluster and figure out how to model the data into it. There's a set of standard patterns that Netflix has figured out, templates or recipes. So there's 10 easy recipes for those things that people keep doing over and over again and getting wrong, right? So the recipes are there, and they act as consultants, and they are mostly that team is people that, 5 years ago they were Oracle DBAs and MySQL DBAs, and now they're sort of Cassandra DBAs, kind of. So they understand that transition really well, what works and what doesn't work. They also do the live monitoring of Cassandra and updating it, so there's a continuous process running all the time, driven by Jenkins, that It's just updating the Sandra nodes for the latest version. And they find a new version, they run through it. But what they do is they take every machine they have a test. And if that all works, they then go to production and update all of that. But then it's like 3 months have gone by and there's a new version of Cassandra, so they do it again. So there's a continuous rolling update to Cassandra for yeah.
Speaking of Cassandra, what do you think about data? Same life cycle, but what do you think about databases?
So that's a good question. How does Docker containers work with storage? That is a big unanswered question, and there are lots of people trying to answer it. Tutorials about how they can right now. The one that's out there that people might have run into is Blocker, which is Cluster HQ. It's a ZFS-based solution. There are lots of other people saying, no, we've got a better way of doing it as opposed to the stealth mode right now. Ultimately, you want to be able to do something that's a bit more like the way people expect around the environments, right? There's a way to keep storage around with the instances of the VMs. So yeah, there needs to be a better way of provisioning storage around. Watch this space probably in the next 6 months. These things will start to mature. So the same problem applies to networking. This is part of that whole Docker ecosystem. So what you want to do is start up right now. If you have a piece of Docker that hasn't been done yet, it's greenfield. There's lots of
Yeah.
because there's one that we have to get taken out for.
There's a global Docker hackathon happening tomorrow. Global is like worldwide. There's a chapter here in Tel Aviv. It's going to be 6 tomorrow at Google. So everyone who wants to pitch in to fix Docker in some way can come, and the prize that the global winner will get is tickets to DockerCon 2015. So anybody is interested, find the Docker Meetup and come tomorrow.
I'll be at DockerCon Europe yesterday. I got my paper accepted.
Next week is heavily dependent on Cassandra, and I've heard some horror stories from time to time, and I've heard about alternative solutions like Meetup. Could you elaborate regarding Cassandra?
I think there's horror stories about every database. So it's certainly possible to break Cassandra. The Netflix automation made it very repeatable and very basically put a whole lot of and tune that automation until things work. So also typically avoiding the very latest version for a while. So I'd say that Cassandra, in my experience, has been one of the more bulletproof systems. I don't think there was data. Occasionally they might get some crashes, or one particular build might sort of randomly crash complex things or restart stuff. But it's been one of the. It was definitely going into it with like poke it, see if it works, and if there was improvement, back up and try something else. But it seems to be fast. So React is another good product. It has its own set of horror stories. Like Mongo has its horror stories, everyone has their horror stories. But for some use cases, Mongo is brilliant for small stuff. React is great for some of the things that DynamoDB has its place. There are a lot of good technologies, each of them is really important.
How do you justify or explain the use of Docker or over pre-baked AI performance wise?
So Docker versus pre-baked AIs, the deployment time is faster. So that's what well, yeah, typically the way you use Docker is you pre-allocate the CC286 large, 150 gigagram, then you point Mesos at it, and you drop a whole bunch of containers in it with that Mesos from the containers for you or something, right? So there are people that would have individual instances. So this is going in 2 ways. First, the CC286 large is more efficient because CPU and memory costs less than lots of little instances. Right? Some of the Amazon pricing is linear, but in general, the really small instances end up costing more per whatever than bigger ones. Right? There's more overhead. The other thing doing is you're operating some overhead in tapeouts instead of in every container. So you end up getting more memory. You're much more memory efficient than Docker. A lot of the payback comes from that memory efficiency. Your ranges are 10 size or something like that, so you can get 10 times. If your memory constraint runs CPU constraint, you get 10 times more stuff.
You actually scale up instead of scaling out. I thought there was an expected running
So you're building another sort of platform layer, which is sort of equivalent to having a whole bunch of machines in your data center that you just file or you can use the data center to do it, right? So what you're doing is you're using Docker to make it fast and deploy things and to do much better memory sharing. The memory efficiency is most of the payback. CPUs, you should put it all on.
But we're using the microservices architecture, and we have different security groups for every service. So then it doesn't make sense for us to file out different
Right,
containers.
yeah. Okay. So the security side, yeah. If you care about the security isolation, then yeah, you wrap your Docker containers in individual VMs, and the solutions are being worked on. So that coming soon. I think Docker is both a kind of, in some senses, it's already arrived. In other senses, it's got one way to go. But the excitement around it, I mean, it's huge. And I think people are probably underestimating the impact of it in the longer term. Although right now, it can look a bit overhyped. I think it's going to make a huge difference.
I think it's like the next cloud. Like you see Amazon, AWS, like replacing all their big instances will be just Docker containers on the same.
Not everything, but I think all of the cloud vendors already support Docker to some extent, and they will all support Docker more going forward. Those two things. Right? So I think we're out of time. Right?